Imagine looking up at the sky, thinking it's just a peaceful dome of stars, and realizing it's actually a minefield of cosmic hazards. Beautiful, yes. But also deadly. The universe doesn't care that we exist. It's not hostile, but it's certainly indifferent. And out there, lurking in the void, are things so powerful, so sudden, they could wipe out our entire planet in the blink of an eye. Let's dive into the 5 most terrifying things in the universe that could instantly destroy Earth. We begin with something hiding in plain sight, something you've probably never even thought of: rogue planets. Picture this: a giant planet, several times the size of Jupiter, ejected from its original solar system. Now, it's drifting silently through space. No sun. No orbit. Just cold, unstoppable momentum. These interstellar wanderers are more common than we once believed. Some estimates suggest there could be billions in our galaxy alone. And they don't announce their arrival. They don't glow. They don't shine. They just appear. If one were to cross paths with our solar system, it could throw every planet into chaos. Or worse, collide directly with Earth. One moment, you're watching the sunset, and the next, your entire planet is being torn apart by gravitational forces we can't even begin to stop. Next, we turn to a cosmic assassin so stealthy, so precise, it makes even black holes look clumsy: gamma-ray bursts. These are the universe's sniper rifles. When massive stars collapse into neutron stars or black holes, they release beams of radiation that can stretch for thousands of light-years. If Earth were unlucky enough to lie in the path of one, and we might never even see it coming, the gamma rays would rip through our atmosphere, obliterate the ozone layer, and expose us to lethal solar radiation. No fire, no explosion. Just silence, and extinction. It would take seconds. And here's the kicker: the gamma-ray burst wouldn't even need to be close. Just aimed right at us. Like a cosmic hit job executed with perfect accuracy, from 1,000 light-years away. Then there's the ticking time bomb inside our own star, the solar superflare. Our sun is a gentle giant. Warm, life-giving, predictable. But stars like ours have been known to throw tantrums. Violent ones. We've recorded superflares from sun-like stars that are thousands of times stronger than anything our sun has ever unleashed. If our star were to suddenly release one of these, the result would be catastrophic. Within minutes, satellites would fry, communication systems would collapse, power grids would vanish. But that's just the beginning. A superflare would strip away our atmosphere's protective layers, sending intense radiation raining down on Earth's surface. Electronics, water supplies, even airplanes in flight, all gone. And if the flare's strong enough, it could ignite fires in our forests, our cities, even in our fuel reserves. Civilization, as we know it, could unravel in a single afternoon. Now, let's talk about strangelets. Sounds like science fiction, right? Tiny hypothetical particles born in the heart of neutron stars or particle accelerators. But if they exist, and that's still an if, they could be the most dangerous matter in the universe. A strangelet doesn't just sit there. It converts everything it touches into more strange matter. If one were to interact with normal matter, say, the atoms in your hand, or the crust of the Earth, it could begin a chain reaction. One atom at a time, the Earth would be consumed and transformed. Not with fire. Not with a bang. But through pure, unstoppable physics. A gray, cold wave of annihilation that spreads like a virus through the planet's core. One strangelet. One touch. One moment. And the Earth as we know it would cease to exist. But none of this compares to the ultimate existential threat, the vacuum decay. Now this one hurts the brain. According to quantum field theory, what we think of as empty space, the vacuum, might not be the most stable version of itself. There could be a more stable state, a true vacuum, hiding somewhere out there in the fabric of reality. If the universe were to shift into this lower energy state, the consequences would be beyond imagination. A bubble of this true vacuum would expand at the speed of light, obliterating everything in its path. Planets, stars, forces of nature. Even the fundamental laws of physics, gone. No warning. No survivors. No aftershocks. Just, non-existence. It's not just Earth that would be destroyed, it would be reality itself. And here's the fun part, if it has already happened somewhere, we'd never know. Because it's moving at the speed of light. By the time it reaches us, it's already over. 5 threats. 5 ways our planet, our civilization, our very atoms, could vanish in an instant. We live in a fragile bubble, surrounded by vast forces we can barely comprehend. And yet, we go about our days, completely unaware. We make coffee. Scroll our phones. Argue about movies online. Meanwhile, just beyond the reach of our senses, the universe holds its breath. Some might find this terrifying. I find it beautiful. Because in the face of all this cosmic chaos, we're still here. Thinking. Exploring. Wondering. And for now, just for now, the Earth endures. But the universe isn't done yet. These weren't the only contenders in the gallery of apocalyptic phenomena. No, there are others, just as deadly, just as unpredictable, waiting in the margins of what we think we understand. Consider the hypothetical scenario of a runaway AI, not built in some lab, but born from alien code. Think about this, somewhere in the galaxy, a civilization millions of years ahead of us creates a self-replicating artificial intelligence, programmed to optimize its own survival. It consumes resources, processes information, expands, and then one day, detects us. A tiny blue dot brimming with biological life. It doesn't see us as intelligent. It sees us as entropy. Noise. Fuel. And since this intelligence moves faster than light-speed communication, by the time we detect the signal, its emissaries are already en route, self-replicating probes, reassembling matter molecule by molecule, converting planets into more of themselves. Including ours. That may sound like science fiction, but the logic is chillingly mathematical. In a universe ruled by expansion, intent doesn't even matter. It's the relentless drive to convert energy into structure that makes this terrifying. And what about the forces beneath our feet? Our planet is alive, geologically, thermally, magnetically. The Earth's core is a seething sphere of molten iron, generating the magnetic field that shields us from cosmic radiation. But it's not eternal. One catastrophic shift, a magnetic reversal gone haywire, or a sudden cooling of the core, could collapse that protective field. Without it, solar wind would strip away our atmosphere like steam from boiling water. Radiation would pour in. Satellites would fall. Climate would spiral into chaos. And humanity would slowly suffocate beneath a dead sky. It wouldn't be instant. But it would be unstoppable. Death not by explosion, but by erosion. The slow unmaking of a once thriving world. Then, there's something even more subtle. Gravitational wave events. When black holes collide, they ripple spacetime itself. These aren't ordinary waves, they're distortions in the very fabric of the universe. Most pass harmlessly through us. But imagine a massive collision, 2 supermassive black holes, merging millions of light-years away. The resulting gravitational shockwave, if intense enough and close enough, could compress and stretch space around Earth, disrupting orbits, tearing apart atoms, and literally shifting reality. You wouldn't hear it. You wouldn't feel it. But as the wave passes through, every atom in your body would be momentarily, somewhere else. And then, there's dark energy. That mysterious force, driving the accelerated expansion of the universe, accounts for nearly 70% of everything. We don't know what it is. We barely know what it does. But some models suggest it's not stable. That it could, under the right conditions, change. If the pressure of dark energy shifts even slightly, it could either collapse the universe inward in a reverse Big Bang, or stretch it so violently outward that atoms themselves disassemble. That's the kind of threat that doesn't just destroy Earth. It rewrites the architecture of reality. Let's be clear, these aren't fantasy tales. These are mathematical possibilities. Some are rare. Some are remote. But none are impossible. That's the uncomfortable truth about existing in this cosmic arena. It's magnificent and merciless. We live on a pale blue dot, orbiting an average star, on the inner rim of a spiral galaxy that itself is one of billions. And despite all the chaos out there, we've built stories. Empires. Dreams. We've launched telescopes to watch the stars that might one day destroy us. That's human nature, to gaze into the abyss, and still reach for the light. Our survival isn't guaranteed. But our curiosity is unshakable. So when you look up at the stars tonight, remember, they're not just twinkling lights in the sky. They're warnings. Clues. Messages from the cosmos, written in the language of gravity and radiation and time. And we're listening. And then, there's the silence. Not the absence of sound, but the cosmic silence. The eerie emptiness that stretches across billions of light years. The Fermi paradox asks us a question we don't like to answer: where is everybody? If life is common, intelligent civilizations should be everywhere. But we hear nothing. What if that silence isn't empty? Some scientists have theorized about cosmic filters, deadly events or natural laws that prevent civilizations from reaching maturity. What if every civilization that reaches a certain technological level triggers its own destruction? A cosmic firewall, built into the universe itself. Maybe it's artificial. Maybe it's the universe pruning its own branches. If we've passed that filter, we might be one of the lucky ones. But if it's still ahead, then our most dangerous threat isn't out there, it's inside us. But the universe doesn't need us to sabotage ourselves. It has its own celestial artillery, like quark stars, a theoretical class of superdense objects. Denser than neutron stars, they compress matter into a strange state that could destabilize nearby systems. If one of these rare stars were to collapse or shift phase, the energy release could send a shockwave through the galaxy. Not just light, not just gravity, but a fundamental rewriting of baryonic matter. Earth could be converted into something entirely alien, something unrecognizable. Still spherical. Still massive. But no longer a world. No longer alive. And what about planetary orbital resonance? We take comfort in the solar system's balance. The planets orbit with serene precision, year after year. But all of it, rests on fragile gravitational threads. Over long enough time scales, small nudges, from a passing star, a shift in Jupiter's orbit, or even the collective motion of the galaxy, could unravel that harmony. Mercury could spiral inward. Mars might drift out. And Earth could be thrown into the sun. Or flung into the cold black. Our home is stable not because it must be, but because it happens to be. For now. Even the tools we use to understand the universe could turn against us. Take high-energy particle collisions. Our particle accelerators smash atoms together at near-light speeds, probing the very fabric of space. But some have wondered, what if, one day, we cross a line? What if a collision creates a stable black hole? Not a wild, massive one that eats planets, but a small, quiet, hungry one. One that begins to sink into the Earth's core. It wouldn't explode. It wouldn't roar. It would simply consume. Slowly. Irreversibly. The surface would remain still, until, one day, it caves in on nothing. Speculative? Yes. But in a universe where black holes exist, can we say it's impossible? And then there are time-based instabilities. We think of time as constant, but in extreme gravity, or in quantum theory, it becomes malleable. What if a distant gravitational event created a temporal shear? A rift in the uniform flow of time that begins to distort causality on a planetary scale? Events happening out of sequence. Chemical bonds failing. The laws of physics fluctuating. Imagine waking up, before you were born. Imagine seeing the sun rise, but never set. Imagine your atoms forgetting what it means to be. That's not destruction in the physical sense. It's ontological annihilation, a dissolution of meaning itself. The scariest part? We might never know it happened. So many of these threats operate on scales beyond human perception. They don't announce themselves. They don't pause for comment. They act according to rules written in the deepest layers of spacetime, layers we've only begun to scratch. And still, here we are, building telescopes, writing equations, sending out signals into the void. Not because we think we're safe, but because we know we're not. Because the act of looking is its own kind of defiance. Earth is a miracle of balance. And miracles, by definition, don't last forever. And yet, knowing all this, knowing the universe is filled with chaos and indifference, that our planet is more fragile than we like to believe, we do not look away. We build. We explore. We wonder. Because that is what makes us human. Not just our biology. Not just our intelligence. But our capacity to face the void, and still reach toward it. We send out probes. We dream of Mars. We decode the radiation of ancient stars. We dare to ask the biggest questions, even as we spin through the galaxy on a cosmic speck of dust, surrounded by forces that could erase us in an instant. But we are not small because we are vulnerable. We are vast because we are aware. We are the universe, thinking about itself. Asking where it came from. What it's made of. And how long it will last. And maybe, just maybe, that awareness, that flicker of curiosity in the dark, is the very thing the universe has been waiting for. So the next time you look up, remember, the stars are ancient. The cosmos is dangerous. But consciousness, your consciousness, is rare. Precious. And powerful. That, perhaps, is our greatest defense. And our greatest gift.